Hey guys, Villani here. Are you okay? So today I'm gonna show you how to do outlines on occluded objects. So if the objects are behind walls and stuff, you'll see their outlines. If they're not, they have no outlines. Like my character here. I turned on this option on him, so as his feet are below the ground, I can see outlines behind his feet. I can put my camera behind him, but I can do it here. So he also has outlines. The only caveat on this material is that if two objects set to have outlines are overlapping, you don't have an outline between them. Oh, and also objects set to have outline block the outlines of objects behind them. That's very hard to overcome, but mostly this is a very useful effect for many things. And the things you're gonna learn for doing this effect can be very useful. So let's begin. So I'm here on the third person template project, and some things we gotta do for this effect to work. First, you're gonna go to Edit Project Settings, Engine, Rendering, Post-Processing, and the CustomDepth stencil pass, you gotta set it to Enabled with Stencil. The default is only enabled. We're gonna need the CustomDepth pass and the stencil pass, so both of them. Can close this. On your objects, only the objects you want to have outlines on, you gotta turn on their properties. You go to Rendering, and then on Advanced Properties, it will probably be like this, so you gotta expand here on the down arrow. Turn on Render Custom Depth Pass and Custom Depth Stencil value set to some value that's not 0, so we can set individual colors for these objects later. So I've done this in this cube, on the other cubes there, on the sphere that's outside my wall, and on my character I had to select its mesh component to access its rendering properties. And I set them each for a 1, 2, 3, and 4 value. That's because I want to have a color for each of their outlines. And the amount of colors you have depend on how many colors you put on the material. I'm gonna put 4 colors so I can have up to number 4. That's it for scene setup. Now let's create a material. Because post-process effects, they are effects that happen on the already rendered scene. So that's a texture, and you can alter this texture. In Unreal, you do that using materials. So I'm gonna create a material. I'm gonna call this PP for post-process _ outline tut. Double click it. Now to use this as a post-process material, I have to change the material domain to post-process. So now I only have an output of emissive color. So that's whatever I put here will go to the screen. So just to show you how it works, I'm gonna create a scene texture node here. The scene texture node gives you access to the buffers of Unreal, everything it renders to create a scene. So the scene color would be what's rendered on the screen without any post-processing, but you can only use this in standard materials to do other kinds of effects. For post-process materials, if you want the scene color, use the post-process input. So if I get this and multiply by some color, for example blue, I'll turn my scene into blue. But I can't plug this directly on here because this is a vector 3 and this is a vector 4, because there are values here that need the four parameters. So as I only want the first 3, I'm gonna use a component mask. So RGB. Plug this here. Emissive color. Now that's alright. If I plug this here directly, you can see we have an error because flow 4 and flow 3 cannot be multiplied. I'll compile my material. And now to see the material here, I have to create a post-process volume here in volumes. A post-process volume alters everything that has to do with post-processing. color, motion blur, bloom. For example, if I come here in global and crank the saturation to 0, I should have my saturation as black and white here. Why it is not? This is because you only see the effect when you are inside the cube, the volume. To see it outside the volume, to affect your whole world, turn unbound on. So now it affects the whole world. I'll turn off my saturation change here. To use post-process materials, you come here on rendering features, post-process materials. This is an array, so you can use more than one at the same time. I'll create one here. Here you have to choose asset reference because we're not doing light propagation volume blendables. And on the asset, choose your material. pp underscore outline tut. So now you can see the blue effect I did on my material. Now let's go back to the material. It is working, so now we can do the outline effect. To do the outline effect, we're gonna sample from the CustomDepth texture. Let me show you how this texture works. First of all, it has only one value. That's the distance on each pixel from the pixel to the camera. So we only use the red channel. That is the first value. After we got this channel, this is the distance of each pixel to the camera. So as Unreal uses centimeters, practically everything here will be more than 1. And if it's more than 1, I can't show you directly here because the texture will be fully white, because textures are only from 0 to 1. So I'll divide this, hold D and click, by some big value like 100 meters. So 100, the divider, 100. And as Unreal works in centimeters, I have to add plus 2 zeros. So it becomes centimeters. I'll plug here in emissive color, apply. Let's see the effect. So as you can see, everything that's not rendering on the CustomDepth channel, as we set them to, is white. This white is a very high value. I don't know this value exactly, I wasn't able to find it, but I know it's greater than 100 kilometers. So we're gonna consider everything that's 100 kilometers to be the furthest possible. And as you can see, my sphere is a little brighter than my character here. That's because the closer something is to the camera, the smaller the distance is. So that's what we're getting here, the distance to the camera. I'm gonna stop dividing this here. We need to recognize outlines, where the background ends and where the object begins. Let me show you how we're gonna do this. Suppose this is our object outline. This is our background and this is inside our object. When you are doing something in a material, everything you do will be executed for each pixel this material is rendered. Since a post-process material is rendered on full screen, we're gonna do math that will be executed for each pixel on the screen. To detect outlines, you read the pixel and all the pixels around it. So, for example, we are on this pixel here. We're gonna read this pixel, this, and this. There are several ways to calculate outlines. The one we're gonna use here will take advantage of the fact that Unreal renders where there's no objects with a very high value. So suppose this high value is 100 and the object is like 1. So the sum of these pixels will be 100, 2, 3, 4, 500. Suppose this will be very aliased. So suppose this is not our material, this is, this, and this. So 100, 2, 3, 4, 500 plus 1, 2, 3 of our material. So 53, actually 553 is our final value, summing all of these pixels. This means the final color of this pixel, if we set this result as a final color, will be 503. It's a very high value. Now if we were on this pixel here, and our grid was like this would only give you 8 times 1, so it's an 8. And if we were a little closer to the border, and our grid picks up even 1 pixel outside of the object, our result is already greater than 100, so like 107 if all of the other 7 pixels were inside the object. So our border here would be rendered also with a high value. That means inside of the object, up to some extent, everything here will have the high value, will be greater than 100. So we're gonna isolate this. Everything that's greater than 100 will leave as white, and everything less than 100 will leave as black. In the case of Unreal, we're gonna have to convert 100 kilometers in 100 centimeters. Let's first sample the pixels around the pixel we're rendering. To do that, I gotta get the current coordinate I'm on. For that, I use screen position. So I have the coordinate I'm on. This is a float tool. It has horizontal and vertical coordinate. And I have to know the size of each pixel on the screen inside UV coordinates. So UVs go from 0 to 1. So each pixel will be something like 0.02, something like that. So we're gonna know this exact size. Pixels in textures can have varying sizes on the screen. This size of the pixel relative to the texture is called texel. So we want to know the screen texel, where is it? Texel, the scene texel size. The scene texel size is also a float tool. It has the horizontal and vertical size of each pixel on the screen. Now that I know this, I can offset my current coordinate by some direction with this size to get the pixels around it. So to offset some coordinate, I use add. I'll hold Ctrl and drag here to leave it more organized, keep lines from crossing. The scene texel size. As I'm gonna have to sample from each direction, up, bottom, left, right, etc., I'm gonna need this size in positive and negative ways and with separate dimensions. So firstly, I'm gonna separate its dimensions with component mask. I want only the red here and only the green here. So horizontal and vertical. And as I'm gonna need positive and negative values, these are positive, I'll multiply by -1 to have also the negative value. Same thing here, Ctrl W. So now let's sample the pixels around this one. Firstly, I'm gonna start with the top pixel. So I'm gonna call this texel because in this case it's the more correct term. So for the top texel, I need to offset this pixel by 0 on horizontal. I have my central pixel, I want to get the top pixel. So my coordinate, horizontally speaking, is the same, but vertically, I walked a pixel up. On screen coordinates, 0 is the left top corner, and 1 and 1 are the other corners. So horizontal and vertical 0, horizontal 1, vertical 0, horizontal 0, vertical 1, and both 1. So for this, I gotta subtract on the vertical. To subtract on the vertical, I'm gonna use the vertical negative value appended with 0. I'll create an append vector node here. This turns single values into float 2, 3, etc. The more you append, the more floats you have on the same value. You will effectively be creating a vector. So I have on horizontal the first value 0, and on the second one the size of the texel on the screen negative. So I have my top texel. Now let's do the bottom one. So I'll sum it with my screen position. Bottom texel. Now to walk down, I need a positive vertical value. Let's only take notes here. This is V and this is U. So UV. Now my left texel. Never forget to plug this on the screen position. So for the left texel, the horizontal coordinate, I'm gonna walk to the left, so it's negative. And on vertical, I'm not gonna change, so it's 0. It will be similar to the right texel, but on horizontal, I'm gonna walk in a positive direction. And now for the diagonals. I'm gonna duplicate this, so it's a little faster. I'll already plug these on my scene texture, actually my screen position. These zeros won't be needed. So now let's get my top left pixel. Top means... Actually, let's name this on the correct order so we don't get confused. Left top pixel, because the horizontal coordinate comes first. So left will be negative on horizontal and top negative on vertical. Here, left bottom pixel. So left is negative on horizontal and bottom is positive on vertical. Now the right top pixel. Right is positive on horizontal and top is negative on vertical. And the last one, right bottom texel. Right? Right will be positive on horizontal and bottom positive on vertical. I forgot to plug this. Okay, everything's plugged on. Now that we have our coordinates, our offset coordinates to sample from all the pixels around the main pixel, let's use these coordinates to sample from the CustomDepth texture. So I'm gonna create a scene texture node here, set it to CustomDepth, and use the coordinate here. I'll use my component mask to get the result of the first number only. That's the only number that counts on the CustomDepth. And now I have to do this for all these other coordinates. Let's copy this, copy these two, and these four. Now these nodes here are the results of the CustomDepth distances at all of these coordinates. Now, as we told before, we're gonna sum these values. So add, so we can check later which of them are greater than our biggest distance and which are not. To create an add node, you just hold A and click, or right click and type add. Now that we have the sum of all the pixels around our main pixel, we can know which of them are greater than 100 kilometers and which ones are not. So for this, I'll subtract that distance from this value. Hold 1 and click here. 100 kilometers converted in meters. Each kilometer is 1,000 meters, so 1, 2, 3 zeros. Now we have meters, and each meter is 100 centimeters. So 1, 2 zeros. What's gonna happen here is, let me show you. Actually, first let me clamp this value. What clamp does is everything that's less than the first number here, the mean, will be converted to the mean. So every negative number will be 0. Every positive number greater than 1 will become 1. Here, I'm gonna compile. Now as you can see, everything outside my objects, the background, is white and my objects are black. And it's hard to notice here, but there's also an outline above the objects. Now what we're gonna do is turn black everything that's the background, but not the objects. Also, something I'm forgetting to do here is we're clamping the values between 0 and 1. But the middle values, 0.5, etc. here, we don't want them. We want 0 or 1. We want to know when something is or not to be outlined. So after subtract here, I'm gonna seal the result. Seal rounds the number up. So if you have 0.5, it becomes 1. If you have 0, it stays at 0. If you have 0.1, it becomes 1. So seal will give us either 0 or 1 after the clamp. We won't have in between values. Okay, that's done. Now I want to know what is background and what is not. So for that, I'm gonna sample the scene CustomDepth again. Gonna get the first component only. I'll subtract. It's the same thing I've done here. So I'll subtract. But here I'm doing it for the mixture of all of these pixels, and here I'm doing it only for the current pixel being rendered. So I'll subtract this big distance here, then seal, clamp. Let me show you what it does. Looks like the same thing as I done before, no? But what we want is to have our background black and our objects white. So then we can multiply the calculation we did before with this one, and the only white things left will be the outlines. So here I have to invert this result. As I have 0 and 1, it's very easy to invert. I have to use a 1 minus node. You can also create this node holding O and clicking. So the 1 minus node does exactly what's written here. 1 minus the value we plug here. So 1 minus 0 becomes 1 and 1 minus 1 becomes 0. That effectively inverted our white and black result. Now, if I multiply this with my previous result, that is an outline kind of inset in the object, the only thing left will be the outline in the objects. So we've created the outlines. What we want to do now is to have these outlines above the original texture, above the original scene. So I'll create here a scene texture node again, but this time I want the post-process input 0 to get my scene as it is. I'll create a lerp And what we're gonna do is use the lerp to mix the scene texture with some color for the outlines. For now, let's create a simple color. I'll call this color 1, as we're gonna have 4 colors later. So I have here my color. I'll do my outlines a very bright blue, so it's easier to see them. Plug here on my B. Oh, I have a problem because I forgot to isolate only the 3 components here from the color. Component mask, RGB. Okay. Now I need an alpha. As you remember, the lerp does the alpha. If your alpha is 0, it outputs the A color, and if your alpha is 1, it outputs the B color, or the A and B values. So I'm gonna put my outlines. They are black where they're not supposed to be outlines, and white where they are supposed to be outlines. So it will work exactly as I want here. Compile. Now I have my objects outlined, but every object with CustomDepth turned on is being outlined. What we want to do is to isolate only the objects which are behind something. To do that, let's go to our material. We're gonna get the scene texture, custom depth, and the scene texture, scene depth. This is the original depth of the scene. Now, if I subtract, let's first isolate the components here. Let's get this mask here. W, Ctrl W. If I subtract minus custom depth from scene depth, I only want objects that are behind the other objects. As my custom depth only renders whatever is set to be rendered on the custom depth, and my scene depth renders everything, the pixels on the custom depth that are behind objects will be greater than pixels that are being rendered on the scene depth, because the pixels being rendered on the scene depth are from the objects that are closer to the camera. So if I subtract from the custom depth my scene depth for objects behind normal objects, the result will be positive. So I can do the same thing I've done here. Seal to have only round values, and then clamp. This will give me 1 for everything behind objects on the scene depth, on the normal scene, and a negative value, or in this case 0 because of the clamp, for objects that are in front of the scene depth, because this would be a smaller value, minus this 1 would be negative. So now I have made white everything that's behind something, and black everything that's not. Let me show you the result here. I like to show the results of these calculations because it's easier to know what's happening. So black is the objects that are not behind something, and white are the objects that are. The rest is also white because, remember, the custom depth renders a very big value where there's nothing. So this will always be behind the scene depth. But as we already have a result that only shows outlines, now we have black 0 to remove from this result with a multiply the outlines that are not behind something. So I'm gonna plug this in the alpha and this in the emissive color. Wait for it. And now my outlines only appear on objects behind something. This little outline here on the bottom of this cube is because it's a little inside the floor. But the rest, as you can see, works normally. Now, before coloring each line according to the object stencil color, let's first do something to control the line thickness, because here they are only being calculated for 1 pixel around the pixel that is rendered. Let's make this something configurable. Let's go to our material. Here's where I decide how far from the current pixel we're gonna sample. So that's where we have to change. I'll create a scalar here and call it line thickness. This gives me the size in U and V of 1 pixel. All I have to do is multiply by the thickness I want. So by default I'll leave it at 2. Multiply. And now I want to use the result of this multiplication on my U and V values. Compile here. Now my lines will be thicker. And if I want to change this in real time, I can create a material instance, call this PPI for post-process instance, use this instead of the original material, and now if I change this line thickness, I can change the thickness of my lines. Also, I can change the color, as I created the color as a parameter. Okay. Now let's do a color for each stencil. On my material, if I sample the custom stencil value, for each pixel not being rendered on CustomDepth, this value will be 0. Oh, and also it works the same as the CustomDepth. It's only one value. It's a float 1, a scalar. So everything that's not being rendered on the stencil will be 0. And everything that is being rendered and you set a different value than 0 will have that exact value, 1, 2, 3, etc. So how can we work with several colors knowing that? I'll create my colors here. Color 1, 2, 3, and 4. Let's set them to different colors. Yellow, black, and something pinkish. I'll rename them color 2 so I remember which indexes they represent. 3 and 4. Oops, 4. Alright. I know which stencil index is being rendered from here, and I gotta do something to choose a color from that index. For the first and second colors, I'll use a lerp, linear interpolate. This will be my alpha, A and B. Actually, I have to put a subtract here. Subtract. I don't have to change by what, it's exactly by 1 that I need. How this is gonna work? We know that because of the way we are choosing the pixels here to render outlines, the only pixels being rendered will be pixels where we have some custom stencil value, unless you forgot to set it from 0 on the object. When this value comes through here, let's suppose it's the 1 value. So it comes through here, 1 minus 1, 0. So on the lerp 0 will output A. That's the color for 1. So that's correct. If it comes as 2, it will be 2 minus 1, 1. On the lerp 1 means B. So we'll have the color for 2. That's also correct. If it comes as 3, we'll have 3 minus 1, 2. 2 for the lerp gives you B very strong. So that's incorrect. So first we gotta clamp these values here so they are only 0 or 1. And now we'll have 1, even for the index of 3. So we gotta do something else. We're gonna do another lerp here. We plug the result of this lerp to be this lerp's 0 value, the A value, The next color will be the B value, the index 3. And if we get this result here, we know it is true. Actually, not this one. We know it is true because of the index 3. So this 2, we want to subtract. So we have now 1, and this will mean B. I'll do the same thing for the third color, and it will be very clear in a while. So here, another subtraction. I forgot the clamp. I must clamp. Alright, now what happens is, if I have 3 comes here, 3 minus 1 is 2. So 2 will become 1 here, and this lerp will pass the yellow color because it's 1. It goes to this lerp. Now this lerp will get the color that came from here, yellow, as its 0 value, and black as its 1 value. And its alpha will be the 2 that came from here, minus 1. So 1 alpha, 1 is B, so it gets the black color. Then it comes to here. Now here it gets the 1 value from here minus 1, so it will be 0, and 0 means it will get the color that came from here, so it steals the black color. So that's how you layer colors according to an index. Now let me plug this in the place of my previous color. Compile the material. And now we have a color for each index. Oh yeah, both of these are the same. It's the other that are different here. Just one more thing I'm gonna do here. If you want your material to always render these outlines, but you don't want to lose all these calculations, you can do a switch to turn this function on and off on the material instance. See, this is why you must comment things. I don't remember where I'm going. Yes, here. Here's where I'm calculating the occlusion. So, occlusion. To comment, you just select your nodes and press C. That creates a comment box. Now, I want to toggle this on and off. So, I think the best place to do this is here. I'll create a switch parameter. StaticSwitch parameter. Call this occluded only, and put this into my alpha. So the value that comes through here, if I set this to true on my instance, it will use whatever's coming here and false whatever's coming here. So occluded only means that I want the calculation as it was before if I set it to true. And if I set it to false, I don't want to use this calculation, so I will use the result that comes from here. Compile. Now on my instance, the default of the, you can set the default. Here the default is false, so it's not render only the occluded objects. Everything that is in the CustomDepth has an outline. If I change this to true, my material compiles again, and now only my occluded materials have outlines. There's a slight problem, as you can see, when two objects which are supposed to have outlines are overlapping. The outline is for both of them. That's because we're detecting the borders between the background and the objects. If you want to also detect outlines between objects, you would have to measure using this technique of sampling all pixels around the object. You have to measure the distance between these pixels, And if the distance is greater than some value, you create an outline. I'm not gonna do this. This is already a very long tutorial, but when you understand what we've done here, you'll see that it's not that difficult to implement this functionality. I hope you learned a lot from this video. If you want to learn something specific, leave a comment and I'll do a video on it. If you like this one, click like and subscribe. Also, share and tell your friends about it, because the more people watch my videos, the more I can dedicate my time for doing tutorials. Thanks for watching, and until the next video.